a little more notation around the questions that we've already seen on this particular graph. Okay? I'm going to estimate f of 3. So here's where x is 3. Now f of 3 means the value of the function f when x equals 3, and that'll be a y value. So we estimate f of 3. Well, we do that. Okay, we project up from 3 and over. And right here is our value of f of 3. Now, I wrote y equals 33 previously. Now I'm going to write y equals f of 3, approximately equal to 33, and a little arrow indicating this. Okay? Estimate the solution of f of x equals 40. Okay? So I can write here. Well, actually, no, solution of f of x equals 40. Okay. Here's the horizontal line where f of x equals 40. So what I have down here is solutions of f of x equals 40 here, here, and here. And a little more notation. The solution set of the equation f of x equals 40 is the set 6, 7.3, 14. And I should say the estimated solution of that equation. Okay? Hello, Tom.
How are you, Dave?
Doing all right. Good. Okay, now we're going to estimate f of 0. Okay, well, here is our estimate of f of 0, because of course x is 0 here, and right here is where we cross the graph. So I could write f of 0 is approximately 16. That was the estimate that we used. So just another notation. Okay, estimate the solution of f of x equals 0. Well, let's use a unique color here. Okay, f of x equals 0, y is f of x, so that means y equals 0, and that happens on the x-axis. The graph crosses the x-axis at this point. So this is the solution of f of x equals 0, and then we've got this arrow here sketched so that we don't confuse it with the curve. And there it is. That's a little bit of notation. And there's one other important way of indicating these things, okay, of representing the values of functions. Okay, let's go back to the estimate of f of 3, which was 33. We got it here, okay? I can draw a vertical arrow, which is what we call a vector, and the length and direction of that vector from the x-axis, where x equals 3, up to the curve. The length of that vector is f of 3, so I can put f of 3 next to that vector, and that vector represents the value of f when x equals 3. I can similarly draw 3 vectors here. And I can say that, okay, this vector is at least what we estimate to be f of 14. And this vector here, normally I want to label vectors on the left, but these two vectors are too close, so I'm going to say f of 7.3. And this vector would represent the value of f of 6. F of 6 isn't a vector, but the vector represents the value of that. That's coordinate. And then I can indicate that f of 6 is about 40, f of 7.3 is about 40, f of 14 is about 40. And this vector notation is going to, vector representation of the value of a function is going to be important, or going to be useful when we start transforming graphs of functions.